I like Bell's philosophy in the way that they design their aircraft. As a pilot, I really like that. You have that confidence that the aircraft's sort of over-prepared for what you're about to ask of it. We are in our hangar here in the Napa County Airport where we keep our Bell 429, and it's a wonderful location to be at our base of operations. I'm Christian Palmaz. My family owns and operates 3 companies here in California: Palmaz Vineyards here in the Napa Valley, a material science company based in Silicon Valley, and also a Wagyu cattle ranch in the High Sierras called the Genesee Valley Ranch. First time I got to experience 429, Greg brought the aircraft down and we decided to pick a particularly challenging environment. I knew the aircraft had a lot of power, had a lot of capability, but I wanted to show the aircraft in the environment in which we were showing limitations with our current single. And that was Lake Tahoe, up at Truckee, high density altitude, hot day. We were able to take the aircraft up there, load it right to max gross, and have impeccable control. The aircraft did not feel like it was operating at max gross.
When Christian and I first flew together, it was the middle of summer, so we had a density altitude of over 9,000 feet. We loaded to maximum gross weight, were able to take off straight up, and then on that takeoff, fail an engine using the Bell 429 OEI training mode and fly away safely, showing that the helicopter, in fact, would carry his family to safety in the event of a single engine failure. From that point forward, he was like, I think the 429 is the way to go.
And then additionally, going into mountainous environments with high winds in the mountains, the aircraft handles turbulence very well. The way that the rotor system is very quick to adapt and it's very, very nimble. The aircraft just seems to be very sure-footed. It behaves like it's much heavier than it is. Here in the Bay Area, we don't get a lot of convective activity, obviously a lot of IFR flight. Putting the aircraft in very turbulent conditions, in thunderstorm environments, really showed the stability and the capability of the flight director and the autopilot. I've never seen the autopilot disengage on a 429, even in some pretty severe turbulence. The aircraft is particularly well suited for challenging IFR conditions like you often will find in San Francisco, where you're getting dumped in above the glide slope, expected to fly faster than you're normally shooting those kinds of approaches. The flight director can handle a lot of complex situations that I've seen other flight decks struggle with.
The aircraft has such an excellent behavior in turbulent conditions. The rotor system does such a great job, and the way that live mount system, the way the transmission and the dampers in the aircraft handle vibrations, really just behaves so well. And you can tell the engineers had those inclement weather conditions in mind, the way that these aircraft are used.
The safety factor is enormous with the 429. You need to have that confidence in the aircraft when you're flying IFR over water. You need to feel that the aircraft is not only has that built-in redundancy, but has that built-in safety. One of the best features about the 429 is its speed. It's so fast. And most of the time with aircraft that can go fast, you're taking a penalty in the ride. The vibrations start to pick up, the ride quality starts to go down. But in the 429, it's as smooth in the hover as it is at 148 knots. It's incredibly quick and efficient. Get it up to altitude, you're burning under 450 pounds an hour at altitude, and you're moving, you're going places. Another really important feature about the aircraft is how quiet it is. We're landing these rural environments. Flying neighborly is really important. Also, there are new regulations coming up every time with Bay Area noise abatement procedures. So the aircraft has some unique features with a split tail design, the staggered rotor system that really allows the aircraft to have a very low noise signature given its weight class.
When people bring up the tail rotor concept versus other types of anti-torque devices, I would tell them that we very much looked at all those different anti-torque devices and found that the efficiency of the tail rotor gave us better high altitude hot day capability. By doing the X pattern with shorter tail rotor blades, it gave us the same noise signature, if not quieter, in many flight environments than other anti-torque systems. Christian's case, the mission really dictated what type of aircraft he was going to pursue. He was looking for a twin-engine, IFR-capable helicopter that was large enough to fit his family.
The cabin space in the 429 is enormous, and the modularity of the cabin is what allows you to take a lot of stuff or people and then very quickly reconfigure the aircraft. And so that ability to go from that enormous cargo area into the cabin, remove seats, reconfigure things very quickly, pull the carpet out, get to the load lock latches. The aircraft can be what you need it to be. think my favorite feature about the 429 is actually that it's just so balanced. A lot of aircraft in this segment tend to do one thing very well, but they'll sacrifice in other things. So maybe they can carry more, but they're much slower. Or they have a larger cabin space, but they'll have higher vibrations in flight. So this aircraft, I think what's like its best trick is that it does all of these things really well and at a pretty reasonable operating cost. For us, it's that confidence to be just a one-ship operator and have the support and not feel like you're just the one-ship operator.
Then when you go and actually fly the helicopter, that's what really drove him to the 429. The ease of handling, the ride quality, the simplicity of the systems, those all really kind of sealed his decision to move to the 429.
I have a lot of reasons to want to stay in this family of products and excited to see what comes out next.